Hello everyone. In this video, let's see DSBSC modulation, that is double sideband suppressed carrier modulation technique. If you recall AM signal, suppose AM of t, or we can write it as S of t, will be equal to AC cos 2 pi fc into t. This is the carrier signal, plus AC into MA divided by 2 into cos 2 pi fct plus 2 pi fmt. This is upper sideband, plus AC MA by 2 into cos 2 pi fct minus 2 pi fmt. This is lower sideband. So this minus indicates the lower sideband, fc plus fm indicates the upper sideband. So this is the spectrum where this is the modulating signal with low frequency. This indicates the spectrum of the carrier signal with high frequency, and the modulated signal will be having three components. This is lower sideband component, upper sideband component, and this is the carrier component. So in the expression itself, we will be having three components, 1, 2, 3, 1 indicating the carrier and 2 indicating the upper sideband, 3 indicating the lower sideband. So this is the AM wave what we are going to get. Here the thing is that we will be having a carrier, we will be having LSB and also USB in AM wave. Means this carrier is not at all having a information. This is just a carrier signal. This will be having information, this will be having information. Means this will be having a information of a modulating signal, this will be having a modulating signal, this will not be having a modulating signal. So removing this is the concept of DSBSC. So without having a carrier signal, only upper sideband and lower sideband can be transmitted. Let us look into DSBSC now. DSBSC means double sideband suppressed carrier modulation technique. This consists of again a modulating signal m of t, and as usually we will be having a carrier wave c of t. This carrier wave frequency fc should be greater than fm again. The same condition satisfies here also. So s of t will be equal to c of t into m of t. So AC cos 2 pi fct into m of t will be the expression. Here modulated signal after the modulation undergoes a phase reversal. You can see over here, whenever the modulating signal or the message signal crosses 0, modulating signal is this, it is crossing 0 over here, means it is going down, means negative. At that time, if you look at the modulated signal over here, it is changing its phase. Phase is going to be changed. That will be called as phase reversal. So in DSBSC modulation, whenever the message signal crosses the 0, the modulated signal changes its phase. That is one concept we need to remember. And the envelope of the DSBSC signal, this is different from the AM wave. Why? Because here also in the AM wave we are going to get the carrier. Now there is no carrier at this position. So Fourier transform of this S of t for a DSBSC modulation will be this expression. Now if you look at the spectrum of DSBSC AM, this is again a Fi indicating the modulating signal frequency, or we can also treat it as FM if you want. So this is the modulating signal, and this is the carrier signal, that is let it be m of t, this is c of t. So this is FC, higher frequency than FM. And the DSBSC modulated signal, if you look at, this is the maximum amplitude we are going to get at the lower sideband and the upper sideband, and you can see there is no carrier over here. There is no carrier indication here at FC. Only upper sideband and lower sideband we are going to get. And also at this stage you can see the phase reversal. Whenever it reaches, or whenever the modulating signal crosses 0 point, there will be a phase reversal. Here also at this point you can observe there will be phase reversal. So in all the places you can observe there is a phase reversal over here. The two concepts you need to remember in DSBSC is that there is no center frequency FC in the AM modulated wave, and there is a phase reversal whenever there is a crossover at 0 of modulating signal. And to generate this DSBSC AM, we need to have a ring modulator. This ring modulator consists of 4 diodes. This 4 diode arrangement will be a form of a ring. So the name itself indicating it is a ring modulator. It is a generation of DSBSC AM. So in the next video, let us see how this ring modulator works. I am going to generate the DSBSC AM wave. Thank you.